All right, here we go. First one. We're going to call this next law called the reflexive. Going to write reflexive. Reflexive property. Oops. Of congruence. We've seen a reflexive before, but that was of equality on page 1. Computer's down right now, Toscano. Think of page 1. We did, at the bottom of page 1, we did reflexive property of equality. That's when we have an equal sign. Now, it also holds for congruence. So watch this. Congruence. If, ready, here we go. Say again? Oh, shoot. Need more coffee, sorry. Where you at? Nice. Okay. Thank you, Chang. If, watch this now, write this with me. If segment, let's say segment AB is congruent to AB, then, ready, Rodriguez? Then segment AB is congruent to segment AB. What? In other words, anything is congruent to itself. Think of the word reflection. In your reflection in the mirror, you're congruent to yourself. You're the same size as yourself. Remember, that's what congruence means, the same measure. Right, Rivetta? Yeah. You got that, right? You're not right. Everyone's writing stuff down and you're not. So you're just trying. Can you just write that down on the third one? And we'll talk about it later. Just write it down and we'll. Then, okay, so if AB is congruent to AB, then AB is congruent to AB. Yeah. Every segment's congruent to itself, or every angle is congruent to itself. That's pretty obvious. It's almost painful to even think about it, so obvious. Next one. Symmetric property of congruence. Symmetric property of congruence. You're going to have to write in such a way where it all fits, so no FYI there. So this is the second to last row now, symmetric property of congruence. Okay. Think of symmetric property of equality. What took place symmetric property of equality up here? Let's see. If A is equal to B, then B is equal to A. All we did is swap both sides. If A is equal to B, then I can switch both sides. Well, we can do the same thing if it's a congruent statement. So watch this. If AB is congruent to, let's say, segment CD, remember these mean line segments. Who can finish it for me? Then what? Nice. Not equal to, but what does that mean again? Got it. Congruent, huh? It's congruent to AB, rock and rolling. It's almost like painful to think about it, so obvious. But these are laws of mathematics, laws of logic, if you will. Last one for today. Rodriguez, is kind of like crazy stuff. Don't worry, I'm going to get you caught up. It's nothing too crazy. Stay with me. Last one is going to be transitive property of congruence. Transitive. property of congruence. Remember, this is like Gizmo and Dinglehopper and Thingamajig. You'll see it when you watch the video later. Or Toscano Martinez can tell you about it later. What happened? Nice. Or Dinglehopper. Or Doohickey. Here we go. Watch this though. Look at this chain of argument. If, watch, AB is congruent to segment CD, comma, and segment CD is congruent to segment EF, comma, then what? Look at the chain. Then what? Not equal, but what's the movie? Nice. Look, you guys. A, B, and CD, CD and EF. Then I can say AB is congruent to EF. Right, Rodriguez? Look at this. Like a chain. I use Rivera, Toscano. Franco, how old are you? Chang, how old are you? Okay. Rivera 17, Toscano 17, and Chang is 17. Watch. Rivera is the same age as Toscano. Toscano is the same age as Chang, so therefore I can say that Rivera is the same age as Chang. That's transitive property. That's all it means. It's like a chain argument. You're his age, he's his age, so therefore you're his age. It's a chain. We're going to do one example now. Watch. Just one example, and you're going to do your grade check and credit check. Watch. So I'm not sure if you have enough space on the back, because we did some already. So if you have space on the back of your law book, put this example down. If not, get a different sheet of paper. I have paper right here for just one example. Go and do that, please, while I set you up. Again, you mentioned it. Beautiful. Look at, I'm going to write that as my first statement because given is always your first statement. Let's write it down with me. Here we go. I'll put it in black here. Going to write T is the midpoint. T is the midpoint of SU, of segment SU. Given. What gives you the right to say that? Well, given gives us the right. Remember, I'm always asking you what gives you the right to say that. This is argumentation now. That's statement one, ladies and gents. All right. What does midpoint mean? Right in the middle. So if T is right in the middle right here, right? What can I say about ST and TU? What can I say about them? Nice. Logically, right? Logically, if T is the midpoint, then I can say, that's my second statement. Watch this. I can say that ST, look at segment ST, is congruent to segment TU. Why, though? What gives you the right to say that, Rivera? So he's absolutely right. The reason's perfect. And what I'm going to write for that reason he just stated is the definition of midpoint. That's what it means to be a midpoint. If something's a midpoint, then the two other segments are going to be the same. That's the definition of a midpoint. That's my reason. That's what gives me the right. Go look at right. Definition of a midpoint. There's no fancy schmancy reason from our law book that we have to refer to. I can say this based on the logic of what a midpoint means. This word midpoint means ST and TU have to be the same. Very good, Rivera. Definition of a midpoint. That's what this definition gives me the right to say this second statement. I need those of you who have been here, I need you to be focusing now. I'm taking to a higher level of proofs now where we say, well, that's the definition of that, so it has to be that. Watch this now. Look what I'm going to say now. What I'm going to say now is going to kind of trip you out. And I'm willing to give an extra stamp for someone to give me the reason that gives me the right to say what I'm about to say. Look at this. Watch this. Toscano. What gives me the right to say number 3? Well, look at from 2 to 3. What's the difference? So what does this mean? What does that mean? So I went from congruence to equality. I went from saying, look, the segments are congruent, so the measures are equal. Where can I get that on these past 2 pages? Is there something there that tells me that congruence means? Symmetric is when you swap. I didn't swap though. Look at. Reflexive is if I wrote the same thing. Look, I went from congruence to. I said, look at 2 segments are congruent. That means the measures are equal. Extra stamp. What gives me the right to say that from my law book? From here. There's somewhere here. Good try. I didn't add something to both sides. No, check this out. Also, Toscano, we weren't dealing with equality. We were dealing with congruence. There's no addition property of congruence. Transitive? ST is TU. Actually, I just went from congruence to equality. It's the same statement. But look at this. There's only a multiplication of equality. I went from congruence. There's no multiplication of congruence. Look, I went from congruence to equality. I'm saying 2 segments are congruent, therefore the measures are equal. What is that? What's the definition of congruence? The definition of congruence. No, you said something else. You're trying to play me. Good try though. I'll tip my hat to that. Here we go. If 2 segments are congruent, then I can say the measures are equal, because that's the definition of congruence. That's what it means to be congruent, for heaven's sake. So go to write definition of congruence. Yes, but I'll help you. What I'll do on the quiz, I'll provide the statement. You just give me the reason. Rodriguez, focus. Here we go. Statement 4. Look what I'm going to do. 7x equals 3x plus 20. What gave me the right to say that? How did I go from statement 3 to statement 4? What gave me the right to go from statement 3 to statement 4? That's kind of weird. One more time. Toscano's on fire. Substitution. Substitution, property of equality. We substituted ST with what ST is. Look at, for heaven's sake, look at the picture, you guys. ST is 7x. So I substituted ST with 7x, and then I substitute TU with 3x plus 20. It's in the picture. I substituted. Hold up, watch this though. Was this on page 1 or page 2, the substitution property equality? It's on page 1, look at it. It is right, it was the 4th one. 5th one actually, right there, substitution property equality. So far we're forming a beautiful argument here. Look at this argument, it's awesome. It's serious deductive logic here. Most teachers can't even do what we're doing right now, believe it or not. Go ahead and tell them. Now what? How do I get x by itself? What do I do to get x by itself? What do I subtract from both sides, please? Close. 3 what? 3x. So if I subtract 3x from the right and 3x from the left, let me write what results from that. It'll be a 4x equaling a 20. Look, I took away 3x from both sides. Wait. What gives me the right to say that? We didn't divide both sides by jack. What did we do? What did we do to both sides? We subtracted both sides by 3x, right? Subtraction. I'm gonna abbreviate subtraction SUBT, subtraction. Thanks, Toscano. Property of equality. Nice. Now look at, we're going to prove. Remember what the mission was to prove x equals 5. We're there. X equals 5. Why, Toscano? What'd you divide both sides by? Right, you've divided both sides by 4, this will result. So what gives me the right to say that? Well, the division, I'm going to abbreviate again. Division, property of equality. Rocking and rolling. Look at this airtight, logically sound argument. Every step, we backed it up with appropriate reason. This is called logic. So yes, deductively, we argue this way. Inductively would be other types of argumentation. Yeah, that's great stuff. You're polishing your thinking skills. Say again? I'm a math teacher already. You should. I would like you to see you go into law school. That'd be cool. Him too.